Today I'll be showing you guys how to create this vine tooth for yourself, where you can just click in one location, then click in another, and it'll create a chain vine here. Just click on one, click on the other, and you'll see that not only does it actually connect the two, but it also does a little bit of a hang, and that can be controlled here. If I go ahead and control the max hang to be something like 800 and the min hang to 500, you can see we now have a lot more of a hang between them, and that hang is automatically calculated through some math. So now I can just click wherever I'd like and make vines for one section to another super quickly and very easily, just like that, all with the help of 5.7 PCG mode. So let me show you how it's all set up. To get started, make sure PCG is enabled by going to Edit Plugins, searching PCG, and make sure PCG here is turned on and restart your engine as needed. Now I'm starting with this. This is just a bunch of the free Megascan stuff. Well, used to be free, I guess still free if you click the redeem button. I don't fully understand how that whole thing is done, if you can get it anymore for free. I don't know. I'm just using the Megascan stuff. The vines are Megascans and everything is kind of just default. Theoretically free stuff you should be able to get, hopefully. But we'll go ahead and get started by creating the PCG graph itself by right-clicking, going to PCG, grab myself a PCG graph, an empty graph. I'll just call this PCG_vines and open it up. Now right away, before we put anything in here, let's go to the detail panel and open up the tool data. Now this is what controls the PCG mode thing, so we can actually use it. For the display name, this is what it's going to appear as when you select it. I'm going to call this vine tool. You can put a tooltip, for example, spawn vines from one point to another, so you know what it does. And then we need to add in the compatible tool tags. For us, we only need to add one, so add one entry, and this is going to be our paint tool, because that is the tool that we're going to be using. The initial actor to spawn can stay as an actor, but if you have something you're trying to attach this to, like your own blueprint, this is where you plug it in. And then you actor label, what do you want to call it once it's created? I'll call this PCG_vines. That way, when I'm trying to search in the outliner for it later on, I can search by vines or PCG and it'll come up for both. And I'll go ahead and enable it as a preset. Once you have all this set up already, you should be able to go in the top left corner, change selection mode to PCG or hit Shift 9 by default. And then you can go to Paint, select the Paint tool, and then you'll see there's the Vine tool right there. And if you select it and you see your PCG vines here, then you're good. Actor label, PCG vines, just as we set type of actor, perfect. I'll go ahead, cancel out of here, so we can go ahead and actually set this up now. The first thing we need to do, of course, is get the information of what we're actually placing in the world. So I'm going to right click and search for Get Tool Data. This is the node that gets the information from the paint, but it needs to know that it's from paint mode that we're getting this from. So for the tool tag, just like in the other one, we'll call it paint tool. And the data instance is basically, what do you want to call this set of data that we're painting? Because you can paint multiple layers. You can paint specifically vines, you can paint maybe rope and flags or whatever else. And maybe they're all in the same graph. This is like, which one is this one? And the data instance here will just be vines. If I reselect the vine tool here, you'll see data instance vines. And if you had multiple, they would show up here. That's all this is. But since we only have one, that will be the default. So the way this is going to work is we're going to click in one location, click on another, and we want a nice vine there. And then we want to click another and another. And every pair we effectively want to create into vines. But when we actually click on the points, it all comes in as one piece of data. We need to split it up into its own pieces of data. Every second one. To do that is relatively simple, actually. All we need to do is just use a divide node, and we need to divide this by 2. And what are we dividing by 2? For input source ones, we need to change that to index, because we're dividing the index by 2, and the output target can be a new attribute. We'll just call it vine. So if I pressed A on here, and then in the bottom left, select debug, select our actual debug here, and then went ahead and clicked in one location and another location, and maybe one more and one more, so we have 4 points total. Back here, you will see there's our 4 points, and if I scroll to the right, you'll see we have vine, 0.5, 1, and 1.5. Now, I don't want decimal points. I want full values. So I want both of the first ones to be 0, both of the second ones to be 1. I could use a floor here, so that way all the numbers will go down. The 0.5 will become 0, and the 1.5 will become 1. Or you could change this type. This is a float, which is why it's outputting to a float. So if I right click here, I can convert it to an integer 32, and then type into here. And now you'll see the vine is 0, and then 1. No floor needed. We're good to go. So now we can go ahead and split this up by this vine number. So then we can use an attribute partition, and we can even leave it on last, because that is the last attribute we were using. You can see vine here is 0, and if I drop it to 1, here's the 2 ones. Now, to make sure that I don't accidentally put something in between and forget, I will change this to specifically use vine. So excellent. It is now partitioning the 2. And now what I want to do is I need to actually, for each of these points, I'm going to need to create a spline between them, but I also need a midpoint. And that midpoint I need to drop down, but not only do I want to drop it down, I want to move it height between the 2 points relative to how high up each one of them is from the other, right? Because if you have 2 points side by side and you have a slope, it'll meet in the middle. But if one is higher, then the slope will be closer to the lower point or vice versa. Now, personally, I'm not great at figuring that kind of calculations out, which is why I just used AI to help me and give me the formula that I need to do this, which I'll be showing with you guys. But that does mean we are going to need a new loop. So I'm going to right click, go to PCG, grab a new PCG graph that is empty. It's going to be our PCG loop underscore hanging spline. That should be fine. Then I'm going to click and drag it right into our graph and choose the bottom option for a loop node. And then we can just double click and open it up. For the input here, I have the in points here, allowed type points of a loop. So we're looping on all the points and that is set to required. The second one is an attribute set that is required again. That's called minimum hang or min hang. Then we have the same one, just max hang, again, required attribute set. The output is just a regular point here that is set to type normal. So we're going to be piping in our points and how much do we want to hang. So let's go ahead and set that up already. We're going to take this attribute partition and just drag it all the way through into the endpoints. It'll convert it to point data, which is great for us. And then we need 2 variables here. So in the bottom left, I'll go to graph parameters, add ourselves a new parameter. I'll click on it and press F2 to rename it. It's going to be our min hang. I'll leave it as a float and we'll set it to be something like 150. And then we'll add a new one, F2, max hang, and this will be 300. So it will go between 150 and 300. And then we'll drag both of these out into here and then plug them in. And once we do that, it no longer gets grayed out because now we have all the required pins plugged in. And then let's go back into the loop. So what we're going to do is we're going to separate the 2 points because now every single one has 2 points. We're going to split them up. So we have the first point and the last point. We're going to find the middle point, and then we're going to reattach all 3 of those separate points in the order we want, because that middle point, when we're adding it, needs to go actually in the middle and not at the beginning or the end of it. So the way we split them up is very simple. From the in here, we can do a filter attribute. And we're basically going to change the operator to be equals. And we're going to compare it to the index here. So when the index is equal to what? We're going to give it a constant threshold. So that way, when the index is equal to 0, it'll be inside filter. And since we only have 2 points, the outside filter will only be the other point. To figure out where we want to actually have this hang happen along the spline, we need 2 things. We need to know the difference in height between the 2 points. And we need to know the distance between the 2 points. And using those 2 bits of information, we can actually calculate it. We'll go ahead and start with the height difference. And for that is relatively simple. From the inside filter, we'll just drag out and use a subtract node. We'll subtract the inside filter from the outside filter, but we want to specify what we want here. So I'm going to hit the plus sign, go to point position, and we want to position .z because we only want the height. And we'll use the same thing for input source 2. Subtract one's height from the other, and then I'll change the output here to height difference. So we'll go ahead and output that information to height difference. Now, depending on how you clicked, the first one might be lower than the second, or it might be higher than the second, which means you might get a negative value here. So all we need to do is drag out and search for ABS for absolute, and that will just make sure that the value that we just got is now fully positive because we're getting the distance, and that should always be positive. And from here, we need to square this value. So we need to multiply the distance by the distance. So we'll just use a multiply here, and we'll literally just plug it in just like that. All of these is using at last here on the multiply, on the absolute, and that's fine because here on the subtract, the last attribute that we worked with was this output targeted height difference. So if I pressed A on this multiply and scroll to the right, you'll see there's our height difference of 10,818. And it's that high because we did square it. You can look at the subtract here and you'll see our height difference was actually 104. Again, absolute made it a positive value and that got squared. That's how we got to this number. So now we need to do the same thing, but for the distance. Now for the distance between 2 points, I want to ignore the height because we do the height in one area. We don't want it to do in both areas. So we want the horizontal distance. So I'm going to drag out from this inside filter, and then we'll grab this set attribute math operation. What we're going to do is set to 0, specifically position.z. So take whatever point there is and make the z 0, and we'll do that for both the inside filter and outside filter. So we effectively put both of those points, no matter where they are vertically, flat, and now we can check the distance between the two. And to do that, it's very simple. We'll just drag out and search for distance. And we just need the vector operation distance here. We'll plug both both of them in, it is going to complain because in this case, it doesn't know what at last is. So we just specify that you want to use the position of one and the position of the other. And we'll output it to horizontal distance. So compare the distance between the two and output it to horizontal distance. And then just like the other one, we want to then multiply it by itself. So it's going to be squared basically. And then we take one and divide it by the other. So we divide the one that is the height difference by the horizontal distance. And for this, I don't want to output it onto itself. So I will go ahead and say output it back onto alpha because we'll be using a lerp with an alpha and that's where this is going to go. If I press A here, all the way on the right, you will see there's our value between one and the other. This value isn't quite right. So what we need to do now is multiply this by 0.5. So we half this value and then we add 0.5. And we look at this final value here, you'll see their actual value is at 0.583. So it's not quite in the center. It's a little bit off. Now, this calculation might not be 100% accurate. I got it from AI after all. But as you saw, it does a pretty good job recreating kind of the look that I'm looking for. And unless you're really going to be staring at it, you probably won't even notice. So now all we need to do is use a lerp node, and the lerp is going to go off of this add. That is our ratio. And we want to find the position between the 2 points. So we'll go inside filter into in A and outside filter into in B. And for this lerp, we want to lerp between the first point's position and the second point's position based on their blend, which we can specify here as alpha so we don't forget. And the output target will go back to source, which is perfect because that will override the position of this point using this information. So now we want to merge all three of these points. We want to merge them in specific order. So we'll just use a merge points node, and then I'll go ahead and hit this add pin. So we have 3 inputs, so we know exactly the order we're going to plug them in. The first one is going to be this inside filter one. So if I double click here on the top row, I can click and drag out of it and plug it into the in here. And if I double click on the one that's going into in B, that is going to be the end position. So that's going to go into in 3. And the middle point, the one from the lerp, goes into in 2. So we have the 3 positions, but we haven't dropped it down yet. To do that, all we need to do is add ourselves the transform points right between the lerp and the in 2 here. So now we can use this transform points to actually drop this. So we have that hang that we were looking for. So we're going to be using this offset min and max. So I'm going to right click and search for make vector attribute. We want to change this to a vector regular, not a vector 2. So we have all 3. Don't plug it in just yet because it's going to want to convert things because it doesn't know what type it is yet. What we're going to use is these min and max hangs that we created. So from this min hang, we're going to drag out and search for multiply. We're going to multiply by -1. By default, positive, of course, will make it go up. And we want to just put in a positive number, it'll go down. You could put in a negative number and then it will go up, right? Because we're inverting it. Or if it makes more sense to you, bypass the -1 and just make it so you have to put in -1000 if you wanted to go down 1000. Whatever makes the most sense to you. But now that we have this, we just need to plug it into this make vector attribute Z because we want to modify the height. And we want to do the same thing one more time, but this time from the max hang value. So the minimum one, of course, is going to go into the offset min and the maximum is going to go into offset max. And the only thing I want to change here on this transfer points is I want to make the absolute offset to be true. I want to make sure that it's actually moving specifically up and down, no matter what direction the actual points are rotated, because the points will most likely be rotated based off of where you clicked. Because when you click on an angled surface, it will position that angle accordingly. And so we want to make sure that it doesn't actually follow that angle's version of down or up. And then all of this gets outputted from the merge points into the output. So basically what we did was did some calculations to find where in between the 2 points we want to grab. And then we moved that middle point down. And then we recombined them from 2 points to 3 in the order that we want. And now we can go back to our main PCG graph here. And if we wanted to, we could already just use a simple debug here. And you'll already see there's our 3 points. You can see 2 of them in the between. And we can change the parameters here. I can make it drop 500 down. You can see it is dropping lower based on these values. So fantastic. So that's all working. So now we can make a spline from this. So we'll use a create spline. So now we have a spline that's from all 3 points. And now we're going to sample the spline. Now, why are we going to sample the spline? In this case, I want to make it so it samples in less distance than it currently is just wherever they are. Because that way, when we use a spline mesh, it won't try to stretch a single mesh that far and completely destroy the geometry. I want the distance to be a little bit smaller. I also want to add in a little bit of offset here because Vine is not going to be perfectly hanging. It might have some more rigid areas where it slightly moves up, down, left, right. Just give it a little bit of more natural form. So to get that, I'm going to use a spline sampler and we're going to change the mode from subdivision to distance. And I'll leave it at 100. I am going to make sure unbound is turned on and fit to curve is turned on. Fit to curve will just adjust your length ever so slightly, so that way the start and the end point are exactly where you clicked. Otherwise, if the last piece didn't quite fit inside of that 100, let's say it divides evenly and then the last one is like 50, well, normally it would just not put it there. But using this fit to curve, it will adjust that length so that way everything fits nicely through, even though it won't be perfectly 100, which for our case is great. And unbounded means we can just do all of this without having bounds, which we don't have a bounds volume for this, so we need unbounded. But once we go ahead and create this, we can just add ourselves a transform points node, and I want to just offset these points just a little bit. We don't want to offset them in X, because X is forward, so that will be along the spline. We don't want to mess with that. We only want to mess it to be up or down or left and right relative to the spline. So I'll offset it by -20 in Y and Z and +20 in Y and Z, so it gives a little bit of wiggle room. We can make this even more intense if we want to do or you can expose these the same way we just did for the hang, and then you'll be able to control that dynamically. But this little offset is all we need, and this is going to be the main one that we're going to be using now to spawn everything from. We'll start with the actual spline mesh itself. For that, we'll need a transform points node, because this one's going to be just specifically for the spline mesh. I'm going to be scaling it uniformly from 0.01 to 0.05, every single point along this spline that we've created, or I guess now regular points. The reason we're going to be using this is because I'm going to be using the default cylinder that's built into the engine, and the default cylinder is quite large, and we need it to be quite small to actually work as a vine. But once we scaled it, we can use another create spline node, and then we can use a spawn spline mesh here. For the static mesh, I will select a regular cylinder here, and I'll also override the materials here. I have a Megascans one I grabbed that I've desaturated that works pretty well. It's a mossy leaf ground, but I'm putting on the vines, and that seems to work quite well. And then we can close the spline mesh descriptor and open the params, and we change the forward axis to be Z. Because the cylinder is up and down, the forward axis actually is up, so that is why it's Z. And if we take a look already, you can see there's our spline, and you can see we have some wobble and wiggle here, and this is what we wanted. I wanted it to still hang, but I wanted it to feel a little more natural, and it's also thinner or thicker in some areas. You can see this part is a little thinner, this part's a bit thicker, and I feel like it's a little more accurate to what a actual vine would be. It wouldn't be perfectly the same thickness everywhere. It wouldn't perfectly hang down, so this is a great starting spot. Unfortunately, I don't believe there's a way to override this value. I have not figured out a solution to this in terms of just dynamically overriding the material. If you're paying close attention, you might have seen a slot for it in the actual beginning when I was showing it off. That is just because I forgot to remove it for that little clip. But as far as I know, currently you cannot override the material, at least for an attribute. Obviously, you can override it this way. Now they have the vine. Let's go ahead and spawn things from the vine. So we're going to need splines for the rest of these. So we'll use a create spline here, and that will go into our three kind of things that we're spawning. Each one of them will use a simple spline sampler to resample the spline at a different distance. The first one will be set to a distance of 50, and again, it'll be unbounded and fit to curve. Then we'll do another one here of a distance of 25, and the last one here will be a distance of 150. To make it more interesting for all of these, though, we're going to use the max random offset normalized. Basically, it will allow it to not be perfectly distanced across, but the points have a little bit of wiggle room, so it will feel more natural. I'm going to set this to be 0.8 on all of these, so that way all of these points will be a little bit offset from where they would be at this exact distance. So maybe you'll get some really close together or some further apart, which will be again more natural. And now each one of them is going to get their own transform points node and their own static mesh spawner. So this is what we're actually going to be spawning. In this first one, we're just spawning this guy right here, which has a few little branches of leaves, and this is great. But these are for Megascans. And at least in 5.7, where I grabbed this from, there's a slight issue with them. For some reason, at a certain distance, when you zoom in and out of them, because of the LODs, they rotate 90 degrees. I don't know why, because when I actually preview the LODs, they don't rotate 90 degrees. In practice, when you zoom in and zoom out, they do. I have fixed this for my version by changing the number of LODs to 1. Originally, they were 5, and I just changed it to 1. So just know that if you run into that issue, you could change the LODs or just remove them. Now, ideally, they would have LODs, as they can't really use Dynamite, as they are created as masked textures versus full geo. For your plants, I'm sure they'll be fine, but because I'm using the Megascans once and they're having a little bit of issues, I had to do LOD 1 and remove the LODs. But with this now in here, we can take a look at how they're actually spawning. And they're spawning kind of upwards. Well, I don't want them facing up, so let's go ahead and rotate them. That is why we put this transfer points in. We can make the rotation minimum here to be 180. That would face them down, but they're kind of facing down and angled. So it might be better to use absolute rotations here. That way we can make sure that they're actually hanging downwards. But of course, if we use absolute rotation, then they go sideways at 180. So the value that we actually need here is minus 90 in X. And then you could see that they hang, but the actual mesh, as it turns out, and not themselves, is just angled this way. Okay, so if it is the mesh that is just happens to look like it's angled, then that's fine, because we can then rotate it 360 degrees all around in all directions to break up the feeling of it just facing one way. And then the other thing we can do here is make it scale from 1 to 3. And now we have a little bit more interest. And you can see, again, they're all following this original vine here. And I made it this light gray to kind of match with this gray of the actual vines that we're using here. So that's a great start. We can control how many and how dense it is by just changing the sample here. If I change this from 50 to 500, right, we're going to get a lot less of them. But I want a nice dense version, so we're keeping it at 50. And then I'm going to just take this and duplicate it down, and we're going to set up a different static mesh here. I'll press E on the top one so we can preview the different mesh that we're going to set up. For this one is just more of the same kinds of vines, just slightly different, slightly less crazy. You can absolutely have them all be together. This one and the one we just made. This one just has 5 different variations here compared to this one that I felt is just visually a little bit different, and I kind of wanted it more or less everywhere since it was very bushy, basically. For this one, because it doesn't stick out as much, I'm also going to introduce a little bit of rotation on Y. We're going to go minus 30 to 30. And because these are smaller overall, I also scaled them from 3 to 5. So we take a look. This is the other ones that we just now added, right? You could see we have some that are pretty big, some that are pretty small. And you also probably noticed that we now have a big gap here. And that was that randomness that we added. So that way it's not equally spawning everywhere. And if I re-enable the original, we now have far denser areas and far less dense areas all along this vine, which is awesome. And the last one I want to add in are those little vines that kind of just hang down, which is this one here. Again, we'll duplicate this through and plug in the new static meshes here. And that's these guys right here. They're more or less just meant to hang down, at least the way I'm using them. But they are by default vertically up. So on the transform points, instead of a negative 90, it actually needs to be 180 rotation here. And we'll remove the minus 30 on the Y. And for the scale, I'll give it a big range from 4 to 10. And you'll see now we have these vines all going down. They're all facing different directions, just like so. Now, I wish I could use the new tree system that's being set up and created right now. But first of all, it is an experimental feature. And second of all, as far as I know, you can't just add that to anything. You have to use the pre-made stuff and the pre-made trees and the pre-made whatever it is that is already set up for you. So if I want to just bring in my own vines, basically, and I want to use the same system, I can't. If I'm wrong, please correct me in the comments. But as far as I know, currently, there's no way for me to just take any asset and make it work with the system, at least for now. It is experimental after all. But with the vine set up now and the vine tool still selected, we can now just click, and we'll get more vines. Now, there is one thing to keep in mind here. The way we're doing this, right, is filtering from one point to another. So if I click and click, it all works really well. But what happens now when I erase not the points here, but the points on this one? If I erase this, watch what happens. This now connects here. Well, what happened? Well, what happened was we erased a point not at the end, and what we're doing is grabbing one to the next, to the next, to the next. So the order of them matters. When you erase point in the middle, everything after that point will also break down. So it's not ideal. But as long as you're aware of that, you can draw them in order and then erase them back in order and redraw, or of course you can start from scratch, or just keep in mind that as you're doing them, keep track of them and everything will be fine. That is a known slight issue with the system. So I definitely want to flag that for you. And we want to get rid of these. We can hold shift, erase that one. Again, if I erase the one here, these were the last ones that were added. So that's why these two didn't get changed, but the other ones did. Now again, click and put new ones in. Very quick, very easy, wherever we'd like. And we can control, as I showed before, the amount of hang, so that way we can have them hang more or less between all of these. And honestly, again, it is automatically computing it. You can see this one's higher up and the lowest point is around here because this point is lower. So it seems like it does a pretty good job with its actual kind of hang point, if you will. It's not perfect, but it's pretty good. And when you're happy with it, you just hit accept. And there it is in the world called PCG Vines with all of the instant static meshes and everything and all the spline components that were created for it. And while I have used this to spawn vines, you can spawn whatever you'd like using the system. All we're doing is creating a hanging curve effectively and then spawning things on it. Make a rope bridge. You have some flags that you want to kind of tie together between building to building. Christmas is coming up. What about Christmas lights? Do you want to set up hanging Christmas lights everywhere? The point of this tutorial, as always, isn't to show you one thing and you can only use it for this one thing. It's to show you a way of doing something so you can then incorporate it and create all sorts of different things using this method. Now, as always, I will have the project files available on my Patreon if you want to play around with them for yourself. And you can join these wonderful people here who support what I do. It really means a lot. And if you'd like to join the community, all of the links are down in the description below as always. And if you're looking for more PCG tutorials, check out this one right over here to get yourself even more familiar with all things PCG mode.